And now what do I hit to stop it? Wait.
Okay, so I want to derive for you what's called the range formula for projectile motion. So the range formula tells us how far a projectile will go. So let's assume that we've got a projectile that's launched from the ground at some angle theta with some initial speed v0. And this projectile is going to follow a parabolic path, and then it's going to land somewhere. And the distance, delta x, that it travels is called the range. Okay? So we're going to derive how far this thing goes in terms of these two given variables, v0 and theta, and g, which we know. So we're going to start with the kinematic equations. So the kinematic equations that we need are for x, the horizontal position, which is the initial position, plus the initial horizontal velocity, v0x, times the time. And then there would be a plus 1/2 axt squared term here, but that is 0 because in the horizontal direction there's no acceleration. So the x acceleration is 0. And then we've got the y position. Y is y0 plus v0y times t. And then there is acceleration in the vertical direction due to gravity. It points down and it has magnitude g. So it's down, so we have a minus 1/2 gt squared term here. Now, these two equations are going to be sufficient for what we need. There is another way to do the problem where you involve the velocity equation, and I might do that for you at the end, but right now we're just going to stick with these two. Okay, so let's look at these two equations here. So first of all, we want delta x, which is x minus x naught. So delta x is x minus x naught. So if I move this to the other side, the only thing that's left here is my v0x times t. Well, I would be finished if I knew what t was, but I don't know what t was. So I need to use this other equation here in order to figure out what t is. So let's use that equation now. The final position y at the end of the trajectory is 0. So I have 0 equals the initial position. The initial position is also 0. And then I have plus v0yt minus 1/2 gt squared. Now there's a factor of t here and a factor of t squared here. And this is all equal to 0. So I could divide both sides by one factor of t, and 0 over t would still give me 0. So I can get rid of this and get rid of one factor of t here. Now I can go ahead and solve this equation for t. So if I do that, if I move this 1/2 gt to this side, I would have 1/2 gt equals v0y. Okay? So now I multiply by 2, and I divide by g. And I have, just rewriting this neatly, t equals 2 v0y divided by g. Okay, so this is an intermediate result that will be useful to us because now we can go ahead and plug this back into our x equation in order to obtain the range that we want. So now delta x is equal to v0x times t, v0x times t, which is 2v0y over g. Okay, so we could call it a day here if we knew what v0x and v0y were in terms of our given variables, v0 and theta. So we need to figure that out. And in order to do that, we need a little bit of trig. So V0 points off in this direction, and it makes an angle theta with respect to the horizontal. And so we need the two components that comprise this vector. We need the horizontal component, V0x, and we need the vertical component, V0y. And so if I remember my trig, the horizontal component here, V0x, is going to be the hypotenuse times the cosine of theta. So that's V0 cos theta. V0y is this opposite side here, so that's the hypotenuse, V0 times the sine of theta. And now I can plug these guys into here in order to find the range in terms of these angles. So delta x equals, I've got a 2 over g, and then I've got a V0x, V0y. Well, when I multiply these two things together, I'm going to get V0 squared times a cos theta sine theta. Now, that is the answer. It turns out that you can simplify it a little bit by recognizing a trig double angle formula. So it turns out that 2 cos theta sine theta is equal to the sine of 2 theta. So here I've got my 2, and here I've got my cos theta sine theta. So I replace all of this stuff with the sine 2 theta. That gives me delta x equals V0 squared over g times sine of 2 theta. And that's the answer. That is the range of this projectile as a function of the speed and the angle. Let's see if we can make some sense out of this. What we could do is think about what happens for various values of theta. So first of all, if theta is 0, then I'm firing it horizontally. Well, I'm just going to hit the ground right away. And at sine of 0 is 0, so delta x is 0. That makes sense. If theta is 90 degrees, then I'm firing straight up. I just go straight up and I come straight down. My range should be 0. And at 90 degrees, sine of 2 theta is sine of 180 degrees, which is 0. So that also makes sense. So when do I get the most range? When is delta x a maximum? Delta x is going to be a max when this sine is a maximum. Well, the maximum value sine can take is 1, and it does so whenever its argument, all of the stuff inside the parentheses, is equal to 90 degrees. So I need 2 theta equal to 90 degrees, which says theta is 45 degrees. Okay, so that angle gives me the maximum range. Now, I mentioned that there was another way to approach this problem, and that is to use a velocity equation. So instead of using this equation, I could have used the velocity in the vertical direction. So Vy equals V0y minus gt. Okay? If I had used this equation, then I could say, well, if I think about the time it takes to go halfway, so let me call this t 1/2. Okay? If I think about that time, what happens to my velocity here at the top? My vertical velocity goes to 0. Vy is 0 here. My horizontal velocity is not 0. Vx is not 0. In fact, Vx is constant the whole time. So I could figure out the entire time for the trajectory by just doubling t 1/2. So t1/2 I could solve here. So because vy at the top is 0. So I could say t1/2 is equal to, well, it's going to be v0y divided by g. And so that tells me that t, which is 2 times t1/2, is equal to 2 v0y over g. And so you can compare that to what we found from the y equation up here, and you see that they agree. So there's 2 ways to find this total time. You could use either method. After you do that, you still need to plug back into this x equation in order to find the range like we did up here. Okay, so that's a derivation of the range formula. I hope that's helpful. Thank you for watching.